Hi there. So we're going to do something very similar to the last question. My goal here is to give you just some variety so we can mix it up a bit. You can see some different kind of looking graphs. Very similar to what we did last time, let's kind of break this into two groups. We had our green group up here. I guess I can just highlight the whole row, huh? And then this, I'll notice, is quadratic. And if you're a little fuzzy on this, that's okay. We actually do review it a little bit in a future section. But again, one of those things that technically you should know coming into this class. But that's our first group, and we're looking for all x values less than 2. And then our second group is going to show up down here when x is greater than 2. And this is going to be a line. And actually, it might help some of you to list this is a parabola. Okay, so to make our way through this, let me bring out my coordinate plane again so we can graph. Make it large so we can read it. Okay. And I want to do something really similar to what we did in the last question, where we kind of have that boundary line labeled. So it's really clear to us where that cutoff happens, right? Where are we dealing with the green function? Where are we dealing with the blue function? Let me take my line again. We're looking at the value x is equal to 2. So here's 1, here's 2. And I'm going to go in, I'm going to draw my line here. And before I forget, I want to make sure and label this, right? And again, hopefully you saw in the last example, you don't have to label everything, but it's enough so that it's very clear, right? How the spacing and all that works. Okay, so let's look at our first one. We can even call it the first one if we want. But let's look at g of x. G of x is negative 1/2 x squared plus 2. And as always, I recommend at least figure out what's g of 2, okay? So let's do g of 2. That's negative 1/2 times 2 squared plus 2, which is negative 1/2 times 4 plus 2. Those are going to cancel, right? Which is negative 2 plus 2, and we actually end up with 0. Now, that's not super common, but it does happen from time to time. This is an or equal to question, so this is closed, right? We're going to have a closed circle here at 2 and at 0. Okay? So now what we want to do is find some other function values. You can rely on your previous knowledge of how parabolas are graphed. For example, I might note it's reflected, and it had a vertical shift up 2 units. We will, like I said, review some of that if it's been a while later in this section, but that might be good review for you, or it might be helpful if you remember it. Okay, but we can plot some other points. 0 is always a great value. So again, this is the same as doing the table that I did on the last one. I'm just writing it a little differently. This would be negative 1/2 times 0 squared plus 2. This whole thing is 0 plus 2, which is just 2. So we also have the point 0, 2, which is 1, 2. Let me label 1, 2. And that gives us a point right here. And I'll remember, this is not a straight line. It's got some curve and a parabola to it. And I also, again, like I said, we know it's facing down like this. It may not be the whole parabola shape. Maybe let's plug in 1 or 2 more values. There's not like a maximum on this, so plug in as many as you need until you believe you know what the picture looks like, right? You don't have to stop after 1 or 2. So let's try g of, let's go with negative 2. So we've got negative 1/2, negative 2 squared plus 2. So negative 1/2, that's a 4 plus 2. This is going to cancel. We've got negative 2 plus 2, which is also 0. So back here, negative 1, negative 2, we've got a point at 0. So hopefully you can kind of see your parabola taking shape. Like I said, if you want to add more points, by all means add more points, right? I will not stop you. Something like that. So now let's figure out how the blue side of this works. I'm going to scoot this over. Okay. So again, this is a straight line. We only need 2 points to connect the dots for a straight line. And I always want to plug in, here, let's write g of x is 1/2 x, and this is a line. I always want to plug in this boundary value. That's regardless of, I know there's a missing or equal to. It's, again, not a typo. It's not supposed to be there. But that tells you how your function behaves with an open dot on this orange line. So we find g of 2, and that's the only time you find something that's kind of outside of this domain set. Okay, so that's 1/2 times 2, which is, those cancel. We actually just get a 1. So this is the ordered pair 2, 1. So 2, 1, I'm going to put an open circle there and make sure I can distinguish between something that's closed, something that's open. I don't want hybrid between the two. Make it very clear. So this time, our green and our blue middle points are kind of unifying points. They don't line up, right? And that's okay. They don't have to. Let's pick some more points that we can plug in here. How about maybe a 3 or a 4, or just like in the last example, you can use that y is mx plus b kind of notation. And note that your slope is going to be 1/2. If that works for you, run with it. I did that last time, so I'll plug in a value this time. How about g of 4, which is 1/2 times 4, which cancels, and we get 2. So at 4, there's 3 and 4. I'm going to plug in 2. And this one's closed because that value of 4 is definitely on this interval, right? Only this boundary line, when we're missing the or equal to, only that is open. So again, I only need 2 points. Do more if you need more. You can do maybe g of 6. I'm using even numbers because I'm cutting them in half. That works a little nicer, so that's a 3. So you would be at 4, 5, 6. Okay, and I could put another point here, right? Or you use your slope, or lots of options. Okay, connect the dots, an arrow in that direction. And just like last time, I'm going to erase kind of the excess stuff. We don't want to clear the whole thing. The orange is not really a necessary piece of this. I'm just going to get rid of it. Okay, so we have this weird Frankenstein graph that's kind of pieced together from a whole bunch of different places, but that's okay. We've got one more in the next example.